Raw mix design for raw mill and kiln cement operation. The first goal in preparing raw materials is a thorough understanding of the raw materials available for the needs of the cement plant. Most cement plants are built at or near their calcium oxide source, as limestone represents about 2/3 of the mass of clinker. The composition of limestone, which is generally the most important source of calcium, will determine all the additional raw material requirements to be selected. The main objective of the design and preparation of raw materials is the kiln feed, which enables the effective and energy-efficient production of Portland cement clinker. Raw mix formulation. There are two equally important goals in designing the raw mix at a cement plant. On the one hand, the mix must be burnable, that is, it must be possible to achieve an acceptable free lime content in the clinker with a reasonable burning zone temperature, without suffering significant reductions in the production level of the kiln or inordinately short brick life. On the other hand, market considerations dictate that the composition of the cement be carefully controlled, that is, the contents of C3S, C3A, alkalis, and MgO must be held within fairly narrow, prearranged limits. The parameters of both types to be controlled are as follows: burnability parameters and compositional parameters. Lime saturation factor, to control content of C3S. Silica ratio, to control silica ratio. Alumina ratio, to control content of C3A. Content of coarse quartz, to control content of MgO. Content of coarse calcite, to control content of alkalis. Definitions of burnability and compositional parameters. Lime saturation factor, or LSF, a measurement of the degree of conversion of silica, alumina, and iron oxide to their most highly basic calcium compounds. LSF is %CaO divided by 2.8% SiO2 plus 1.18% Al2O3 plus 0.65% Fe2O3 normally equals 95 to 99%. Silica ratio, or SR, a measurement of the ratio of silica to that of the sum of aluminum and iron oxides. Inversely proportional to the liquid phase at burning zone temperatures. SR is %SiO2 divided by %Al2O3 plus %Fe2O3 equals 2.3 to 2.6%. Alumina ratio is a measurement of the ratio of alumina to iron oxide. This ratio can influence the rate of development of clinker liquid in the burning zone. In the presence of 2% or more MgO, a ratio of 1.63 gives the maximum liquid phase at the minimum temperature. AR is %Al2O3 divided %Fe2O3 equals 1.5 to 1.7%. Content of C3S and others. This is usually calculated using the Bogue equations. While not strictly accurate, it is a good indication of the sort of level of C3S, or alite, that will be experienced in clinker. It is frequently used as a burnability parameter as well as a compositional parameter. C3S equals 4.07 CaO minus 7.6 SiO2 minus 6.72 Al2O3 minus 1.43 Fe2O3 minus 2.85 SO3 equals 60 plus or minus 2%. C2S equals 8.6 SiO2 plus 5.07 Al2O3 plus 1.08 Fe2O3 minus 3.07 CaO equals 16 plus or minus 2%. C3A equals 2.65 Al2O3 minus 1.69 Fe2O3 equals 9 plus or minus 1%. C4AF equals 3.04 Fe2O3 equals 10 plus or minus 1%. Liquid phase equals 3Al2O3 plus 2.25 Fe2O3 plus MgO, about 23%. Raw mix design calculations. The raw mix is controlled either online or offline. In the online mode, raw mill products are often analyzed, and appropriate changes are made to the mix proportions required to achieve the desired target. Deviations from the composition will result in a product with inferior qualities. Computer programs are available to help achieve timely correction of these mixtures, but the mixing installation must be efficient for corrections to be made in a timely manner. Most mixed design calculations are based on matrix models. It is strongly recommended that anyone responsible for mix control be familiar with the matrix calculation based on pairs of materials. Once the process is thoroughly understood, it may be sufficient to use a prepackaged computer program for mixed designs, or to use a trial and error or hunt and peck system in a spreadsheet format. How to calculate raw mix design. As an example, we have four material components: limestone, high silica, clay, and iron sand. And oxide values for each material component, as shown in this table. How to calculate material composition setting for raw mill feed. In order to achieve the LSF, SR, R targets on the kiln feed, and the C3S, C2S, C3A, C4AF, and liquid phase on the clinker quality targets, according to the desired standard. This is a sample Excel sheet for calculating a design raw mix with four material components. First, we determine the set point of the feed material to the raw mill, or determine the proportion of limestone, high silica, clay, and iron sand materials. Second, calculate the mixed oxide for each component according to the feed set point. The third is calculating the composition of LSF, SR, AR, C3S, C2S, C3A, C4AF, and the liquid phase. Steps to calculate the set point proportion of limestone, high silica, clay, and iron sand materials, according to LSF, SR, and AR targets. There are some similarities. Among others are, equation 1 is, to calculate the target LSF for each material component. We group it into four sections named A1, B1, C1, and D1, as seen here using the LSF formula, but reversed because the target already exists. According to the formula we filled in earlier, the result of the calculation is like this. Equation 2 is, for the calculation according to the target silica ratio on the four material components. We group it into four sections named A2, B2, C2, and D2, as seen here using the SR formula, but reversed. According to the formula we filled in earlier, the result of the calculation is like this. Furthermore, equation 3 is, for the calculation according to the target alumina ratio on the four material components. We group it into four sections named A3, B3, C3, and D3, as seen here. According to the formula that was previously filled in, the result of the calculation is like this. Equation 4 is, a divisor in the calculation to determine the proportion of raw mix. In accordance with this formula, then we calculate and the result is like this. Then equation 5, to calculate the proportion of raw mix, each using a formula like this, for limestone is X, high silica is Y, and for clay is Z. The result of the calculation is as shown in this column. Equation 6 is the final determination of the raw mix proportion. Using a formula like this, for limestone or X%, high silica or Y%, clay or Z%, and iron sand Y%, the result of the calculation is like this. This is the final set point of the proportion of raw mix as raw mill feed. The total must be 100%. If it is less than 100%, then corrections can be made like this, so that the total becomes 100%. Next we calculate the percentage of oxides in all material components according to the set point, for example like this. Next we calculate the composition of LSF, silica ratio, and alumina ratio, according to the formula. The calculation results are as shown here, and the results are entered into this column, according to or not with the target we have made. Then, we also calculate C3S, C2S, C3A, C4AF, and liquid phase, and we enter the results into this column as well. If the C3S target does not match the target, then we can change the LSF target, increase or decrease it so that it is closer to the target range. That was an example of a matrix calculation to determine the proportion of raw mill feed set points, and kiln feed composition targets, and clinker quality targets to be achieved. Thank you for watching this video. Hopefully it's useful, and don't forget to subscribe, like and comment, and share it with your friends who need it. See you in the next video.